Are you tired of waiting through countless hours of vague and overstuffed LabVIEW tutorials that seem to drag on forever with little to show for it? Channels like LabVIEW Tutorials for Beginners bombard you with over 100 videos packed with fluff and noise, leaving you sifting through endless content for just a few useful nuggets. And take a look at playlists with dozens of videos, like the one with 37 videos on basic topics or an 8-minute video focusing solely on the front panel. It's clear that these channels require you to spend a lot of time to get minimal, fragmented information. But what if I told you there's a better way? In this video series, we're cutting out the fluff and getting straight to the heart of LabVIEW. You'll get all the essential details, delivered clearly and concisely. We're talking about covering everything you need to know in fewer than 5 videos, with a total watch time of under 4 hours. That's right. Less time wasted, more knowledge gained. Stick with me, and I promise to provide you with the exact information you need, without any unnecessary detours. Hit that subscribe button and join me on this streamlined journey to mastering LabVIEW. Let's dive in. In this first video, a thrilling journey into the core of LabVIEW awaits. We'll kick things off by unveiling the secrets of the most essential palettes. You'll learn how to launch LabVIEW, create and open projects effortlessly, and dive deep into the key components of a virtual instrument UI. Prepare to elevate your LabVIEW skills and bring your projects to life. Let the adventure begin. This video is the first in our exciting 5-video series, so stay tuned for more. To create a new project, navigate to the menu bar at the top of the window and click on File. In the drop-down menu, select New Project. A dialog box will appear, guiding you through the steps to set up your new project. Follow the prompts to name your project and choose its location on your computer. You can also select a template if you have a specific project type in mind. Within your new project, you'll need to create a new virtual instrument UI, which is essentially the main building block of your LabVIEW programs. To do this, right-click on My Computer or the specific hardware target where you want to create the new UI. From the context menu that appears, select New and then UI. This action will open a new UI window, which is divided into 2 main sections, the front panel and the block diagram. The front panel is where you will design the user interface of your UI. The UI has 2 main components, the front panel and the block diagram. The front panel is the user interface of the UI, where you can add controls and indicators to interact with users. You can place elements like buttons, knobs, graphs, and other interactive components on the front panel. The block diagram is where the graphical code is created. It contains nodes and wires to define the behavior of the UI. You connect different nodes with wires to create the flow of data and control in your application. Now, let's focus on the Numeric Palette and its functionality. The Numeric Palette contains functions for performing mathematical operations and data manipulation. It includes basic arithmetic functions like addition, subtraction, multiplication, and division. For example, you can create a simple adder by adding 2 numbers using LabVIEW's Numeric Palette. Place a numeric control for one input value and a numeric constant for another input value on the front panel. In the block diagram, use the addition function from the Numeric Palette. Connect the numeric control and numeric constant to the addition function, and then connect the output of the addition function to a numeric indicator. This setup allows you to input a value using the numeric control, and the sum of this input with the constant will be displayed on the numeric indicator in real time on the front panel. Similarly, if you want to subtract another value from the output of this addition, you can add a subtraction function and another numeric indicator. Connect the output of the addition function to one input of the subtraction function, and connect a numeric control or constant to the other input of the subtraction function. Finally, connect the output of the subtraction function to another numeric indicator. This will show the result of the subtraction on the front panel. You can also use other functions from the Numeric Palette. Use the multiplication function to multiply 2 numeric values. Use the division function to divide one numeric value by another. Additionally, if you need to perform modular arithmetic or integer division, use the quotient and remainder function to get both the quotient and the remainder of a division. If you want to explore additional functions and need help using them, right-click on any function in the Numeric Palette and select Help. This will open a window with comprehensive information on how to use that specific function or palette, including descriptions, examples, and usage guidelines. The Boolean Palette in LabVIEW provides functions for logical operations and control flow. Boolean controls are used on the front panel to create user inputs that can be true or false, such as push buttons, checkboxes, and toggle switches. Boolean indicators display the result of Boolean operations, such as LEDs or lamps. The palette includes several key functions. The INT function performs a logical AND operation. It outputs true only if both inputs are true. The OR function performs a logical OR operation. It outputs true if at least one input is true. The XOR function performs an exclusive OR operation. It outputs true if exactly one of the inputs is true. The NOT function performs a logical NOT operation. It outputs the inverse of the input, so true becomes false and vice versa. For example, to use the INT function, place two Boolean controls on the front panel and use the INT function from the Boolean palette in the block diagram. Connect the controls to the inputs of the INT function and connect the output to a Boolean indicator. The indicator will show true only if both controls are true. If you encounter any issues or need more details about using these functions, you can always access the built-in help system. For instance, if you want to use the Boolean 2, 0, 1 function, place your cursor on it and select Help. Click on Detailed Help to see its function description, which converts a Boolean false or true value to a 16-bit integer with a value of 0 or 1, respectively. The Arrays palette in LabVIEW provides a set of functions designed for working with arrays, which are collections of elements of the same data type. Here's a detailed summary of its main functions. Array controls. These controls are used on the front panel to create array inputs. They allow you to define and manipulate collections of data, enabling the user to input multiple elements in a structured form. For example, you can create an array control to input a series of temperature readings. Array indicators. These indicators are used to display the contents of arrays on the front panel. They show all elements in a single array control or indicator, providing a clear visual representation of the data. For instance, you might use an array indicator to display the results of a series of calculations. Functions in the Arrays palette. Array subset. This function extracts a portion of an array. You can specify the start index and the number of elements to retrieve from the array. This is particularly useful when you need to focus on a specific section of your data set, such as analyzing a subset of sensor readings over a particular time period. To use the Array subset function, place an array control on the front panel and the Array subset function from the Arrays palette in the block diagram. Connect the array control to the input of the Array subset function, specify the start index and the number of elements to extract, and connect the output to an array indicator. This setup will display a portion of the original array based on your specified parameters, allowing you to focus on a specific segment of your data. Array size. This function returns the size of an array, including the number of elements along each dimension. It is useful for determining how many elements are in an array. For example, you might use this function to check the number of data points collected in an experiment. Array max and min. These functions find the maximum or minimum value in an array. They are essential for determining the largest or smallest value in your data set, such as finding the highest temperature recorded during a test. Build array. This function creates a new array from multiple input elements or arrays. It enables you to combine different arrays or values into a single array. For instance, you can merge data from multiple sensors into a single array for comprehensive analysis. Initialize array. This function creates a new array with a specified size and fills it with a default value. It is useful for setting up arrays before populating them with data. For example, you can initialize an array with zeros before filling it with measurement data. If you need additional help with these functions, you can always refer to LabVIEW's built-in help system, which provides detailed explanations and examples for each function. The Strings palette in LabVIEW provides a suite of functions for manipulating and processing text data. String controls are used on the front panel to create text inputs where users can enter string data. They act as input fields for text, allowing users to provide necessary information. String indicators display the contents of strings, showing text data or results of string operations. They act as output fields for text, making it easy to visualize the processed data. Concatenate strings combines multiple strings into a single string. To use it, place two string controls on the front panel, insert the concatenate strings function from the Strings palette into the block diagram, connect the string controls to the inputs of the concatenate strings function, and connect the output of the function to a string indicator. This setup will display the combined text from both string controls and the string indicator. This function is useful for merging different pieces of text into one cohesive message. String length returns the number of characters in a string. It's useful for determining the length of a string. Knowing the string length can be important for validating input or preparing for further string operations. Substring extracts a portion of a string based on specified start and length parameters. To use it, connect the string input to the substring function, specify the start position and the length of the substring, and the output will be the extracted portion of the original string. This function helps in isolating specific parts of a string for detailed processing. Search and replace string finds a specific substring within a string and replaces it with another substring. To use it, connect the original string to the function, specify the search substring that you want to find, and specify the replacement substring. The function will modify the text accordingly. This is useful for correcting errors or making targeted changes within large texts. Format into string converts numeric values and other data types into a formatted string. To use it, connect the format string to the function and connect the data inputs such as numeric values that you want to format. The output will be a custom formatted string based on the specified format. This function is handy for creating well-structured and readable text outputs from various data types. These functions allow for versatile text data manipulation, making the strings palette a powerful tool for managing and processing strings in LabVIEW. With these tools, you can handle a wide range of text processing tasks effectively. The Comparison palette in LabVIEW provides functions for comparing numeric and string values to determine relationships such as equality, greater than, or less than. These functions are essential for decision-making processes within your programs. Here's a summary of its main functions. Equal compares two values and outputs true if they are equal. Use this function to check if two inputs are the same. To use the equal function, place two numeric controls on the front panel and the equal function from the Comparison palette in the block diagram. Connect the numeric controls to the inputs of the equal function and connect the output to a Boolean indicator. The indicator will show true if the values from both numeric controls are equal. This function is useful for validation checks and ensuring data consistency. Not equal compares two values and outputs true if they are not equal. Use this function to check if two inputs are different. This is particularly useful for flagging discrepancies and triggering error handling routines when expected conditions are not met. Greater compares two values and outputs true if the first value is greater than the second. Use this function to determine if one value exceeds another. This can help in making decisions where prioritization or ranking is involved, such as sorting data or implementing conditional operations. Less compares two values and outputs true if the first value is less than the second. Use this function to determine if one value is less than another. It is often used in loops and conditional statements to control the flow of the program based on threshold values. Greater or equal compares two values and outputs true if the first value is greater than or equal to the second. This function helps you check if a value meets or exceeds a threshold. It is useful in scenarios where you need to enforce minimum requirements or limits. Less or equal compares two values and outputs true if the first value is less than or equal to the second. Use this function to check if a value is below or at a threshold. This is helpful for ensuring that values do not exceed specified limits and for implementing inclusive range checks. These functions are fundamental for implementing conditional logic in your LabVIEW applications, enabling precise control over program execution based on the relationships between values. The Cluster palette in LabVIEW provides functions for grouping and managing related data elements efficiently. Here's a summary of its main components and usage. Cluster controls. These are used on the front panel to create and manage a collection of related controls or indicators. Clusters allow you to group multiple controls or indicators into a single unit for easier management. This helps in organizing complex data structures and simplifies wiring in the block diagram. Cluster indicators. These display the contents of a cluster, showing all elements grouped together. They provide a clear visualization of group data, making it easier to monitor and debug applications. Functions in the Cluster palette. Unbundle extracts individual elements from a cluster. Connect the cluster input to the unbundle function and specify which element you want to extract. This allows you to access and work with individual data items within the cluster. To use the unbundle function, place a cluster control on the front panel and the unbundle function from the cluster palette in the block diagram. Connect the cluster control to the input of the unbundle function and specify which element you want to extract. Connect the outputs to individual indicators to display the separate elements of the cluster. This function is essential for breaking down complex data structures into manageable parts. Bundle combines multiple controls or values into a single cluster. Connect the inputs to the bundle function, and it will create a cluster containing the specified elements. This is useful for grouping related data together. To use the bundle function, place several controls on the front panel, example, numeric controls, string controls, and the bundle function from the cluster palette in the block diagram. Connect the controls to the inputs of the bundle function and connect the output to a cluster indicator. This setup will group the controls into a single cluster, displaying all values together on the front panel. This function streamlines the process of organizing and managing related data. Bundle by name, similar to the bundle function but allows you to specify which elements to bundle by name. This provides more flexibility, especially when working with clusters containing many elements. This function is particularly useful when dealing with complex clusters where positional indexing can be cumbersome or prone to errors. Unbundle by name extracts specific elements from a cluster by their name. This is useful for accessing named elements directly without having to know their positions within the cluster. This function enhances code readability and maintainability by allowing you to reference elements by their descriptive names. These functions are crucial for efficiently handling group data in LabVIEW, allowing for more organized and manageable code. They simplify data management, enhance code readability, and reduce wiring complexity, making them essential tools in any LabVIEW programmer's toolkit. The timing palette in LabVIEW provides functions for managing and controlling time-related operations in your 6. Here's a summary of its main components and usage. Wait, MS pauses the execution of the 6 for a specified number of milliseconds. Use this function to create delays or control the timing of operations in your application. This function is essential for managing the flow of your program and synchronizing tasks. To use the wait MS function, place it from the timing palette in the block diagram. Set the desired delay time in milliseconds by connecting a numeric control or constant to its input. The 6 will pause execution for the specified time before continuing. This method is often used to introduce controlled delays in data acquisition or user interface updates. Wait until next MS multiple pauses the execution of the 6 until the next multiple of a specified time interval. This function is useful for synchronizing operations with specific time intervals. It helps in achieving precise timing and coordination in repetitive tasks. Tick count MS returns the number of milliseconds that have elapsed since the system was started. Use this function to measure elapsed time or create timestamps in your application. It is useful for benchmarking, logging, and performance analysis. Elapsed time calculates the time that has passed between two time points. Connect the start and end time to this function to get the duration between them. This is useful for timing operations or measuring performance. This function helps in evaluating the efficiency of processes and detecting delays. Date-time functions provides various functions for working with date and time values. You can retrieve the current date and time, format time values, and perform date arithmetic. These functions are essential for applications requiring real-time data logging, scheduling, or date-based calculations. These timing functions are crucial for precise control and synchronization in LabVIEW applications, enabling you to manage time-dependent tasks effectively and improve the overall functionality and performance. In this video, we explored various essential palettes in LabVIEW for developing effective UI. We began by covering the basics of launching LabVIEW, creating and opening projects, and understanding the key components of UI, which include the front panel and block diagram. We then examined the Numeric Palette, focusing on functions for arithmetic and data manipulation, including basic operations and conversions. We moved on to the Boolean Palette, which provides tools for logical operations and control flow, such as the AND, OR, XOR, and NOT functions. The Arrays palette was also covered, highlighting its capabilities for managing arrays with functions like array subset, array size, and build array. We then explored the Strings palette for text manipulation, using functions like concatenate strings and search and replace string. The comparison palette allows for comparing values with functions such as equal, greater, and less. We also looked at the cluster palette, which is used for grouping related data with functions like bundle and unbundle. In the timing palette section, we discussed managing time with functions such as wait, ms, tick count, ms, and elapsed time. By mastering these palettes, you can effectively design and control your WIAs to suit your application needs. If you enjoyed this video and want to see more content on LabVIEW or related topics, don't forget to subscribe to my channel. Your support helps me create more valuable tutorials and guides. Feel free to leave a comment with any questions or suggestions for future videos. Thanks for watching.